the change divided by the time it took to travel that interval. Average speed, distance traveled divided by the amount of time. Well, I want to be more general. I want to talk to you about average rate of change. The average rate of change of a function so no longer does it have to be a particle traveling along a straight path. The average rate of change of a function over some interval is the amount of change divided by the length of the interval. So see the transition we've made? We haven't done anything different. We're still finding slope. But now we're going to simply say the amount of change divided by the length of the interval. Another concept of the average rate of change can be thought of as, I'm lazy, we'll call it ARC, average rate change, okay? Average rate of change can be thought of as the slope of a secant line to a curve. Now please note, I'm not talking about the trigonometric function that we call secant. I'm talking about a secant line. What's a secant line? You geometry students. What is a secant line? Circle? Does it have to be a circle? On any curve. A secant line is a line that contains 2 points of a curve. So if I've got a parabola that opens downward, if I have this line here, it contains 2 points of the curve. That's called a secant line. A secant line. So what we want you to be able to do in the beginning, I think I can get this one done. I want to find the average rate of change of the function 2x squared minus 3x plus 7 over the interval hello, are you finished?
Yeah, I was afraid to question everything.
Yeah, that's
okay.
Thank you. And again, when we ask for average rate of change, what are we asking for? The slope. Where now, the average rate of change of a function over some interval is the amount of change divided by the length of the interval. So I could maybe even add to this, if I am looking at the interval from A to B, I can think of the amount of change would be f of b minus f of a divided by the length of the interval, which can be obtained by simply taking b minus a. So, the average rate of change so the amount of change, I'm going to evaluate function f at 4. I'm going to evaluate it at -2 divided by the length of the interval, which is b minus a. B minus a. How do I find the value of function f if x is equal to 4? Plug and chug. Do you know how to evaluate a function off of a calculator? Because if I could use a calculator on this problem, you know, I want to avoid any kind of mistakes. So if I want to evaluate this function at f equals, or x equal 4, x equal -2, I am going to clear out what we just did. And I'm going to look at the graph of the quadratic function 2x squared. I have 2x squared minus 3x. Plus what? Thank you. You got my back. I appreciate that. And all I want to do is just graph it. And there's your parabola. Now, if I want to find a function value, I want to know what this function is equal to. I want to know what the y value is equal to if x were equal to 4. So go into calculate. So I got to hit second function, trace. And see number 1 there, value? Click on it. Or I'll just hit number 1. Look what it's done. It's giving me the graph that says, if you can even see it, x equal. Well, I want x to be equal to 4. So if x is equal to 4, and I enter, y is 27. And I guarantee you that's the correct answer. Not that you're not capable of substituting 4 into this quadratic function and coming up with 27 on your own, but why take the chance? You might make a mistake. And then if I want to evaluate at -2, I'll go back into graph, get rid of all that, go back into second function, calculate. I want value, and this time I want this to be equal to a -2. And I screwed up. And that's equal to 21. And in my denominator, I would use that. I just wanted to show you that, share with you that. If you want to use that concept on how to evaluate a function value, You can, if you wanna still just plug and chug, you can, no big deal. So my average rate of change of this function in the interval from -2 to 4 is equal to 1. Pretty straightforward stuff. But then I want to talk to you about tomorrow. What happens if I want to find the average rate of change at a particular instant? Which brings us into, I don't know if you remember or not, instantaneous rates of change. Instantaneous rates of change. And we'll pick up with that tomorrow.